Page 340, lesson 6-7 is on similar figures. So first of all, we're going to talk about what it means if something is similar. If it's similar, then it's similar. No. Basically, it's kind of like it's the same shape but a different size. So it's kind of like if we enlarge or shrink something, but we could also rotate it, reflect it, and translate it as well. So dilations would be kind of a big thing we would think about if something's similar, but we're also going to be looking at rotations, reflections, translations. We've got all four of these things that are going to be in the mix here when we find similar figures. So on example 1, they're asking how can he tell whether these parallelograms are similar. Okay, so to look if they're similar, one thing we can do besides having to go through all those transformations, one thing we can do is look at the side lengths. If we have any straight sides, we're going to look at the side lengths of those. So for example, from D to C, we're going from -6 to 2, or you can count the boxes, that's 8. And it looks like these things, one's kind of flipped over, if you guys can see that. So on this other figure, they didn't use primes or anything. On this other figure, we're going from -3 to 1, so that's a distance of 4. So we've got 8 and we've got 4. We've got another side that's, this one's going straight up and down. So this one, if you count the boxes there, that's 4. And on the other one is 2. So one thing we can do besides looking at necessarily what are all the transformations from going from one to the other, we can look at whether the side lengths are proportional. So we had an 8 and a 4. If we look at the big over the small here, okay? So we had 8 over 4 and we had 4 over 2. What we can do is we can look at whether those sides are proportional. We would also need to consider if the angles are the same length and things like that. Oh, and we have another one here. We've got from A to B, we've actually got a third set. That looks like 5 and 2.5. Okay, so one more. We've got 5 over 2.5. So what we can do is consider whether all those fractions are equivalent or not. If they're all equivalent, then the figures are probably similar. If they're not equivalent, then the figures are for sure not similar. So one thing we could do, if you have the bigger number in the numerator, you could divide these out, or you could try and reduce them. If you divide them out, you'll get 2. If you reduce them, you get 2 over 1. So they all end up the same, and so they are actually going to end up being similar to each other. And here is kind of what I'm looking at in this generalized box. Similar figures have the same shape and congruent angles, and the corresponding side lengths are in proportion. So that's what we were doing. Looking at the side lengths, we were seeing whether the side lengths were proportional or not. So what the book did, they actually did all of the steps to show that these are for sure similar. And so what they did is they first noticed that we would have to reflect this. So they reflected across the x-axis. And then they noticed that the one is obviously smaller than the other one. At that point, what you could do, if you're not sure what to reduce by, just look at points that match up. So this is -6, -2, and this is -3, -1. Okay, so if we're at -6, -2, and we're trying to get to -3, -1, you can see those other ones are half as big. So we'd have to take half of those. And so that's how they came up with the idea of having a scale factor of 1/2. Okay, so it's a reflection and then a scale factor of 1/2, and then we can for sure say that those are actually similar. When we say that they're similar, we can make this similarity statement. So the similarity statement, we've got just this one little squiggly line in between these, and that says ABCD is similar to GHJK. And when we do that, it really actually matters where we put our letters. A is the first letter here, matches up with G. What that tells me is angle A and angle G have the same angle measure as each other. Okay, and if you go back and look at even the original figure, it does look like angle A and G have the same angle measure. And it goes the same for the other ones. B and H are the same, C and J are the same, and D and K are the same. Not only that, we can also look at the side lengths. Okay, we take the first two letters, A, B, and G, H, and we're saying A, B, and G, H are corresponding sides. A, B is up here, G, H down here, okay? Those sides correspond, they match up with each other. And same thing, we can do that for all of them. We can say BC matches up with HJ, CD corresponds with JK, and AD corresponds with GK. All right, so we're saying a lot of things by that similarity statement. So we really want to make sure if we're ever asked to write a similarity statement, we have to make sure we put our letters in the right order. So if we look at the try it, they're wanting us to see whether these triangles are similar. There's no coordinate plane here. There are no angle measures given. So we're mainly just going to be looking at whether the side lengths are proportional. This time they used primes on their sides, so it's a little simpler to tell what sides match up. Okay, so maybe if we look at the AC and A prime, C prime, I like to put normally the bigger number over the smaller number, but if you want to write it the other way and just reduce your fraction, you can do that as well. Either way is fine. So we've got an 18/8. So one thing, if we reduce these by 2, this would be 9/4. If you divide it out, would be 2.25. Okay, and then we're going to look for another set of sides that should be the same proportion if these are going to be similar. So our other numbers that match up, if you look here, we've got AB and A prime, B prime. Opposite order of how I showed them. This is AB, this is A prime, B prime. Anyway, if you put the bigger number over the smaller number again, we've got 27/12. And I guess, let me back up a minute. We don't always want to just say the bigger over the smaller or the smaller over the bigger. We want to make sure we're consistent whether this is the new over the old. Okay? We've got to be consistent on which figure we were starting with and ending up with. So that first fraction went to 9/4. We could think about, what could we maybe do to get this to be 9/4. So you might look at with the 12. To get from 12 to 4 would be dividing by 3. And so we'll reduce our numerator by 3 as well. And we do get 9/4. Otherwise, if you had a calculator, especially if you wanted to divide 27 by 12, and you would get 2.25. So those came out the same. The angles, these middle angles have to be the same. Those are called vertical angles, which you'll learn about later on. Anyway, we don't have a whole lot of knowledge to go off of other than the side lengths at this point, but that's going to be enough for us to say that these triangles are similar. Okay, the one is basically 2.25 times bigger, 2 1/4 times bigger than the other one. The convince me goes a step further and says what sequence of transformations shows that these are similar. So if we're starting with this bottom triangle and trying to get to the top triangle, one thing we'd have to do is a reflection. We don't really have an axis here to look at, but we could pretend there is one there. And then also we would have to do a dilation. So overall, this is what we'd be looking at. We could say a reflection across the horizontal line through point B, followed by dilation of scale factor 2.25 or 9/4 if you want, and center of dilation is at B. So example 2, we have a quadrilateral, and they want us to graph the image by a dilation with center 0, 0, scale factor of 3, and a reflection across the y-axis. So it's kind of just what we did in one of the other sections. It's just that we're adding in the scale factor as an option. If you'll notice, they started with points J, K, and L, and they are ending up with J double prime, K double prime, L double prime, M double prime. The double prime is just an indication that we had two different transformations in order to get to that point. So the first transformation we could do would be the dilation, and then the second thing would be the reflection. Okay, so the first thing, that's what they did. They started out with that original quadrilateral, dilation with a scale factor of 3. So we're multiplying all of our coordinates, x and y coordinates, by 3, and that gives us these points, and they graphed that as the green quadrilateral. So notice those now have primes because that was the first movement that we did, and then from there we're going to reflect this across the y-axis. So again, when you do these problems, probably not a bad idea if you want to even highlight the y-axis so you can think about this is which one I'm reflecting across, and then just you can think about like we've done before, how far is it away from the y-axis. So this is 3 squares away, 3 units away. We're going to go 3 units away on the opposite side. Same thing for K double prime, and then you can go with the same idea for the other ones, and that will get you this new picture. So this is, it's not asking us if they are similar, but it is creating a similar figure. Okay, the figure we created by doing this dilation and reflection is giving us a similar figure to what we started out with. Example 3, they are back to asking us whether these are similar or not. So again, what we could do, we could look at the side lengths. Obviously, we can tell on these trapezoids that the one side is bigger than the other. So we're going to compare our smaller horizontal sides to each other, and we're going to compare our bigger horizontal side lengths to each other. So on the smaller sides, if we look at this from A to B, so from A to B, that's 4 squares. F to E is 2 squares. So we've got a 4 compared to a 2. And then we'll look at the same idea with our horizontal, our longer horizontal sides. So from D to C is 8. From G to H is 4. So if we go again with our, this one they don't have primes, so we don't really know what our new or old are. So I guess we could say it's like our blue over red. Or you could say, you know, A, B, C, D over G, H, E, F, or whatever. Okay, so the question is going to be whether those are proportional or not. So those are actually equivalent. They're both equivalent to 2/1. And then another thing we could do is the book talks about we did a rotation and then a dilation by a half. One thing we can do without going through all of that, we do have to make sure our angles are the same, but we can kind of get around this if we make a triangle here on each one of these. We can actually compare whether the sides on the triangle are proportional. Okay, so this would be 6/2, and this would be 3/1. So we got a 6/2 dimensions on that one triangle. The other dimensions on the other triangle are 3 and 1. So if those have the same proportion that we had earlier, then that's going to tell us that these are similar. And they do. They all reduce to 2/1, so that's going to be another way we can look at this to tell that these are similar to each other. Okay, so you can kind of make triangles or put boxes around the shape sometimes and test whether the side lengths are the same proportion to tell whether these are similar as well. So on the try it, we are going to look at part B, and they're asking, is triangle JKL similar to triangle PQR? Okay, we're going to see whether these are similar. Now, one thing we can do by them asking if these are similar, we can look at the order of those sides. And you might notice on this top triangle, we have one horizontal side, which is PR. Okay, so PR goes straight across. Look at the other one. P and R were the first and last letters here. Look at the first and last letters on our potential similarity statement is JL. So we're going to try to match up PR with JL. Those are two sides that are going to potentially match up if these are going to be similar. So this PR is 10 units and JL is 5 units if we count that out. And then going the other direction, we don't have a straight side, but what we can do is we can kind of box these in. We can kind of create rectangles here, and then we could compare our dimensions the other way. So this is 4 and this is 2. So we could compare those. So we could compare 10/5 and 4/2 and think about if those are the same or not. So these both would reduce down to 2/1, which tells us those sides are proportional. We still would need to double check for the angles. And actually, if you go back to part A, they're talking about a reflection across the line x = 1, followed by dilation with the scale factor of a half. Without doing that, we could even, just notice that we're going to have to, well, that's not going to quite do it. We would have to do a rotation here, it looks like, okay? So what you could do if you get to that point and you just want to for sure verify that the angles are the same, that these exactly match up with each other, you could do a rotation depending which one we're starting with. Let's say if we're starting with JKL, then we could do a rotation by 90 degrees, and then we could do a dilation with a scale factor of 2. because those are all 2 times bigger. Okay, so 90-degree rotation counterclockwise. Oh, that was clockwise, wasn't it? I got confused again. Okay, so 90 degrees clockwise, which would be actually 270 counterclockwise. And then you could do a dilation with the scale factor of 2, and then those should exactly match up with each other. You could confirm for sure that those angles actually do match up. If we look at do you know how number 6, they're asking whether these are similar or not. So AB and DE, AB and DE are in the same spot. So AB and DE, well, that doesn't look like that's going to work. Okay, so they put their letters in the wrong order here on this problem. So it's actually for sure not going to work, but we'll just act like they had them in a different order and we'll just go with it, okay? So if you look at from A to B, that's a length of 3. From F to D is a length of 8. And then if we box these in, we can look at the other direction. So going the other direction here, we got 3 and 1. So what we can do is we can see whether these are proportional or not. So 8 over 3, is that equivalent to 3 over 1? And that actually will not work. 3 over 1 is already reduced. 8 divided by 3 is not 3. That would have had to have been a 9 over 3. So these are not equivalent, and so these are not similar to each other. And we could just say it by that the side lengths would not be proportional. Would be one way of looking at that. So we will continue with lesson 6-7 next time. This gives you a little bit of an idea, and we will finish up next time. Have a good day.